Yes, sir, we are able to see your screen.
Okay, so basically, in today's demo session, we are trying to pursue some objectives, and those objectives are designing a simple user interface with the help of XML language, which we can use to design Android user interface for our application. Second objective is to handle the event. So in Android, when you construct an application, you need to design a user interface, and user interface is an important part of your application as a user usually sees the user interface. In Android, user interface is divided into a two part of views. One we can say is a view group object, and another is we can say a view object. So view group is an object where we can say it as a container. Means we can put some objects inside a container. In a technical language, this view group, or in an Android language, this view group is called as a layout. So layout is a way to arrange the components in a specific format. In this view hierarchy, you can see a view group can contain a view group, and view group can contain a view. So in a view group, either you can put a view or a view group. So in a layout, you can put a layout inside it, or you can put a component inside it. Here, the view refers to the components like buttons, edit text, text view, and many other components which are available in Android Studio library. So basically this view hierarchy is important to us to understand how we can arrange the view in our Android application user interface. Next, we will go to the next part of this view hierarchy. So here I have explained what is a view group and what types of view groups are available in Android. So as I say, view groups are container, are layouts, and most specifically 6-7 layouts are available in this Android library. So there are some layouts like a linear layout, a relative layout, frame layout, table layout, absolute layout, and the grid layout. Those are the 6 basic layouts available in Android core libraries. As well as with the material design from the Lollipop, you will find there are 3 more layouts which are not specified here. One is a coordinate layout, another is a constraint layout, and another is a drawer layout. So most of these layouts are available with the version Lollipop and above, and it has a backward compatibility, so you can run these layouts on the older version like Gingerbread. It helps us to arrange the component in a specific format. So here in this objective, we are going to learn about a linear layout, how to construct this linear layout with the help of XML language, and how we can create a simple user interface like a login in our application. Most probably, this linear layout is nothing but a stack layout where you can arrange the component in some vertical fashion or in a horizontal fashion. So you can place the component like a stack. These view groups are the objects available in the Android library. Same way we are talking about the view. These views are nothing but the components available in the Android library. You can see a button, you can see a edit text. In here, the edit text is nothing but a text field which we saw in a way. Same way we have a radio button, switch, text view, progress bar, and there are lots of components available in the Android library. Each component has a specific behavior, and all those components are available inside android.view.view package, which is basically a view package. So here in Android, there is a base class, we can say android.view.view, because view group and view is a made up of all those classes. The more information about this view and the view group is available over this reference website, which is connected to the developer's Android website. We will get more information like how we can use any of this component in our application, what are the interfaces available on this component, as well as how it behaves on event handling. So here is an example of a linear layout. Here you can see it is an XML language used by Android Studio or Android operating system to design the user interface. It is always an element and sub-element, and it contains attributes. So here are some attributes, most important attributes available for view and the view group. Here you can see the linear layout is an element available in Android, and it tells the operating system now we are designing the layout or the user interface for our application with the help of linear layout. This XMLNS:Android is nothing but an attribute, and it is a namespace for Android Studio to understand how to draw the component and how it looks. Basically, this URL is nothing but a fake URL, and if you try to put this URL inside a browser, you will find nothing. This URL is specifically made for Android operating system to understand how to draw the components. We are going to learn this attribute one by one and how we can apply this attribute to our linear layout or to our text view or to our button. In short, how we can apply these attributes to views or the view groups. So the first attribute is nothing but an ID attribute. This attribute represents a unique identity for your view or view group. That means you can apply this ID attribute to layouts also, to components also. As you can see, this ID attribute is the very important attribute for our application because there are two reasons. First, it creates a pre-compile time memory allocation for that component, and second, it helps us to bind this application or this component from XML file to the Java file. So no need to create a button with a program within a program Java. You can create any type of button with the help of XML file, and then you can bind it to the Java file. Android uses MVC design pattern, and as design pattern, they decides that view will be a different file, and the business logic or the backbone for that view will be a different file. In Android, user interface file is represented with the XML file, and backbone logic is represented with the Java file. So this ID attributes is like defining or declaring a variable in XML. Whenever you are creating a component, you should declare this component with the help of ID attribute. So syntax is very simple. You can say Android:ID is equals to, in a double quote, you can say @+ID. So @+ID is the syntax, and here is the variable name. So you can put any variable name you want, and you can create an ID for the component. The ID creates a pre-compile time memory allocation. Every view and view group has a specific width and height. So those attributes are also required for a view or the view group, that means a layout or the component. The width, it represents the horizontal length for your view or for your view group. It means you should apply this Android:layout_width attribute on the component, and it is necessary. It is must. The values of Android:layout_width. Layout_width is nothing but a syntax, and it is available in Android Studio with the auto intelligence. So you don't have to remember all those things, but you need to remember what is required and what is must for creating a simple user interface. So layout widths can be represented with a value called match parent. Android:layout width can be represented with the value called wrap content, or Android:layout width can be represented with the specific value you require. So first we will understand what is the difference between the match parent value, the wrap content value, and the 20dp value. Assume you have a screen for your application and that screen gives, okay, so let's draw something. So let's assume this is your screen. It is screen width and it is screen height. So when I say the value is match parent, it always takes a width of the same size of your screen. So this is our match parent. This is our match parent. When I say a wrap content, the value wrap content, it means the value is declared for that component in an Android library and it will take the specific value required for that component. If we are applying a text on that component, like button have a label on it, like text view, text view have a label on it, same way it will try to arrange that component in a such a way that it will occupy that all text inside it. So we have a match parent and the wrap content value for our width. Next is, if I am saying Android colon layout underscore width is equals to 20dp, means I am specifying how much width I require. Let's say this is a 20dp. So I am assuming I am creating an view or a view group with the width 20dp. DP stands for density independent pixel and it is usually used in Android as a unit. So whenever you want to arrange the component in a specific size, you need to use this DP unit, that is density independent pixel unit, for your component. Next is the height. It represents the vertical length for your component or for your layout. It has also have the same values as you can see for the width. Match parent. So here it will take screen height as the value for your component. So Android colon layout underscore height is the syntax, and here you can add the value or you can set the value as match parent or the wrap content or the fixed height. Again, this DP stands for density independent pixel. The next is the width and height of the root layout is always match parent. Means whenever you are creating your application, this application is always starts with a layout. And this layout is called as parent layout or the root layout. And this root layout is always start with a match parent attribute. Here in this example, you can see they have used fill underscore parent. It is same as match parent, but from the version Honeycomb, that is API level 15 and above, this fill underscore parent value is deprecated. So from Honeycomb and above, we generally don't use this fill underscore parent value. So here you can see the linear layout is starting with match parent, height is a match parent, and this is the spatial attribute for the linear layout, which says how to arrange your component. Do you want to arrange your component horizontally or vertically? Here, the orientation tells that I want to arrange the component in a vertical fashion. The component always start with, sorry, The component always starts with left top corner. So whenever you are adding the component, you are adding this component at the left top. It will always start with the left top. Depends on your width and height, it will change the size of the component. Whenever we are saying a linear layout with a vertical orientation, that means we are trying to arrange this component in a vertical fashion. That means it is a stacked fashion. It will add a component one by one below one. Okay, sorry for my drawing. Same way, if you say you want to use the linear layout with the horizontal orientation, that means it will try to arrange the component one beside one, like this one. So again, depends on your component width and height, this can be happen. If you try to arrange the component in such a way, then it will try to arrange the component in that canvas, in that linear layout. But if you are adding a more than a component which fits into the screen size, then there is a possibility this component can go outside your application or outside of your screen. So it is our duty to create such a type of user interface that will not go out of bound for our application. Let's erase it. Here you can see the first component is arranged in a linear layout and the first component is a text view. You can see there is an ID attribute which declares the unique representation of this component. Same way, we can see a width attribute which says wrap content and wrap content. It means the text on this text view requires some width and some height. It will occupy inside that. The button they have arranged with the ID button and the width and the height. So Android text is the new attribute for us and it is available on some specific components. So text attribute represents a text information for some use, example like text view, edit text and the button. This Android text attribute and the syntax is like this, and most probably we follow the Android developers documentation to set the string for our user interface. So we put the string in a strings.xml file. The strings.xml file is nothing but a central repository for our Android application where we keep all the string constant in a key value pair. We add some key value pair in our strings.xml like this. That string is the element and name is the attribute. Hello underscore world is the key and hello space world is the string. This strings.xml file is located in res-values directory in project structure, and you can add many more string key value pairs as per your requirement. So we are referring from the string file. You can see @ means we are referring. Here we can change the file as per our requirement, but right now we are referring the string, so it will come from the strings.xml file, and Android Studio named it as string. We are referring a key hello underscore world, which is nothing but we are referring for the value hello space world. So Android text attribute is not available on the layout, but it is always available on the component and some specific component which shows the text on it or label on it. So let's design a user interface in for our Android application. We can fire Android Studio and we can create new Android Studio project in our Android Studio application. So this is the older project. I will close this project. I will close this project first and then we will start with the new project. File, close project. Okay, so we are creating new Android Studio application. This new Android Studio application will create a new application, new project for us. So here we are creating a simple application that is a login screen with a linear layout. Let's say next. Here we are selecting the minimum API level that is where our application is going on. So our application is running from the Jelly Bean to KitKat to Lollipop to Marshmallow to Nougat. That is the latest one. So we are selecting the API level 16, that is the Jelly Bean one. That means we are approximately targeting 95.2% of devices worldwide. Let's say next. Here we will choose a simple empty activity. Then I will say next. And we will keep this activity name and the layout name as it is. The activity name refers to a Java file and the layout name refers to the user interface file which we are going to create in our application. So activity is one basic building block available in Android operating system or in Android, which generally represents a screen. And we are going to create a user interface, that is login user interface for our application. So we are trying to imply all the knowledge we have gained, like we need to remember the ID attribute, the width attribute, as well as the height attribute. Again, we need to remember the values we can set on the components or on the layout with match parent or the wrap content. So this is Java file. We are interested in activity underscore main.xml file. So here you can see when this application gets built, you will find two files. One is Java file and one is XML file. So here we are interested in XML file. Let's go to the XML file. And in this design, you can see how our application looks when it's created from scratch. So here you can see a Hello World application, as it is the latest application, latest Android Studio. It uses a constraint layout and we want to change this constraint layout to the linear layout, as we are targeting the linear layout as our objective. So here we can say linear layout. Linear layout has a specific orientation we need to set. So we are going to add one more attribute inside this. We can say Android : orientation. As you type this, you will find this will automatically gives you the auto intelligence option, which attributes you want to select. So you can select it and now you need to enter the value. So here we need to arrange this component vertically. We can say this is vertical, or if you want to arrange the component horizontally, you can say horizontal. But right now for us, we are creating a login application login screen. That's why we are going to set it as a vertical. You can see it has changed from the center to the top left. As I said, linear attribute starts the component in a in a left top fashion. So first we require one edit text or one text field which can accept a username from our application. So let's add edit text. Edit text element is available in Android core library. You can set it. Once you select this edit text and double click, you will find all the must attributes comes automatically. So here it asks the component you are saying, that is the text field or the edit text you are setting up in your application, what is the width and what is the height for this application. Let's see what if I make it width as a match parent and height as a match parent. In design, you can see we have only one component, which is match parent, match parent. Here you can see a blue dots. That means the first component is arranged and taking all the space on the screen. We don't want like this. So let's change the attribute. Let's make it wrap content. Height as a wrap content and width as a wrap content. So here you can see this first component is arranged at the left top, but it is taking very small space. It is shrinked. So let's make it somewhere that it will look good. Let's arrange the width as match parent and height as wrap content. See, this component is arranged correctly as per our requirement. As you can see on any other application like a Facebook, like a Google application, so you can find this text field always arranged in this fashion. We will add ID to it. So here we can say Android:ID @+ID. @+ID is the syntax, and here we can say username_edit text. Now on this edit text you can see a simple edit text is available in our user interface. This edit text is referred to a username, so we can tell this with the help of a text view. Here we can say a text view, and width is, I can again set it as a wrap content, and height as a wrap content. Android:ID, we can set it to it, and we can say username_text view. We can set the value on this text view with the help of Android:text attribute. Now, as I say, we need to add this value to the central repository of this Android application. You can find this central repository in a project section, that is a project explorer area. Inside app, inside res directory, inside values directory, you will find strings.xml. So open this strings.xml. Let's add one key value pair. So key is, let's say, username_text view, which is same as the ID given to this text view. So username_text view, and the value for this text view will be, let's say, username. We will refer this value from this strings.xml by saying @string/username_text view. So here we can say @string/ and you will find the new key value pair is available inside our string.xml file. So let's refer it. And here inside the design you can see it's a username and its text field. The font is very small, so let's change the font size. There are lots of attributes available on each component, and you need to get all these attributes from developers documentation. So let's say text size as a 20 sp, and here you can see the component has changed the font size. As per your requirement, you can keep changing it, and you can see the changes over here. Next, we require a password, and the password field is available in our edit text. So here we can say we are copying this text view. Instead of saying username_text view, we can say password_text view, and the edit text will become password_edit text. Now, to make this text view, to make this edit text as the password edit text, we need to add one more attribute on this edit text, that is input type. So you need to tell the operating system what type of component is there, and if it is an edit text component, what type of value it can accept. So here I can say text password. So whenever user start typing inside the text field or inside the edit text, it will automatically convert all the characters into a black dot. So let's say text password, and here we require one more string.xml. We can copy this string.xml. We will change this to the password text view, and here we can say password. Refer this password text view on our password text view label. So here you can say username, then there is a text field, password, and then there is a text field. As you can apply this input type text password on this edit text, you can also apply this on the first, that is username edit text, and here we can always say it is only a text. So it will open appropriate keyboard required for your application. If you say it is phone, so it will open a dial pad, so you will be having only numerics. But right now we are very much interested to accepting a text. Again, we require a button for a login. So let's add a button with the help of button element. So this button element is available in Android Core Studio libraries. So let's say button, and it again says the width and height. This time I will say again the width as a match parent and the height as a wrap content, because it looks good on the screen. You can again experiment it as per your requirement, as per your screen design. You can change these values. As you can see, there is a new component available on our screen, but there is no label on this button. This label can be set with the help of Android :text attribute. So here we can say Android :text, and again we require a key value pair in our strings.xml file. So here we can say string name is, I can say login underscore button. Here we can say login. So let's refer it. So here you can see a login is coming on. Again, you can change the font size as per your requirement. So here we can say text size is 20 sp. So that will be a focused area for us. So whenever user finished with entering the credential, he will always come to know that I need to click on this login button. So as you can see, all the components are arranged vertically. First there is a text view, then there is an edit text, then there is again a text view, then there is edit text, and then there is a login button. Now all these components are arranged vertically, but they are very close to each other. So let's add some space to each component so that they can make look good. To add the space between the component, you can use a margin attribute. This margin attribute is available in Android Core library in a different format. As you can say, there is a margin attribute, there is a margin top attribute, there is a margin bottom attribute, margin end, margin left, margin right, and margin start. So they are giving a specific attribute for specific direction from where you want to add the space. This margin attribute will add the space from the top, from the bottom, from the left, that is nothing but from the start, and from the end, that is nothing but from the right. So here I will arrange a margin top attribute because there is a vertical layout we are using, and vertical stack is designed over here. So let's say this margin from top is 16 dp. You can copy this attribute to each and every component, so it will add some space from the top. And here you can check the design. Now here you can see there is a space between username and the password text field and the password and password edit text field, and there is a change in the login. So again, you will always find how to use these attributes on the developer's documentation. Again, to make sure that our components are not going outside of the screen, you can always set a padding. This padding we are going to set on this linear layout. So here we can say Android : padding. We are setting this attribute not on a single component but on the root layout, so it will shrink or it will add the padding to all the components automatically. So here we can say it's a 16 dB, and here is our login screen. To run this application, you can always go to the tools, Android, and Android Virtual Device Manager. In this Android Virtual Device Manager, you can see an emulator, that is a virtual devices to run Android application. You can create one Android virtual device with this option, that is you can select the hardware, you can select the operating system, and then you can say and you can finish. So it will create a new emulator for your application. Right now we are not creating any virtual device because right now we have already two virtual devices available. One is with the Marshmallow Nexus 4 and another is a Nexus 5X with the Lollipop version. So let's run this application and let's see whether we are getting a login screen on our application. So you can press this run button always, and you can choose any of the emulators. So let's say Marshmallow Nexus 4. It will take some time, depends on the hardware requirement on the specifically to run this Android emulator. You need at least more than 6 GB of RAM and i3, i7, i5 processor to run it very fast, very smoothly. If you don't want to run this application on the emulator, you can always connect your real device via USB, enable the developer mode, and then run this application on the real device. You can test this application multiple number of operating system versions which is available in Android Studio. Here you can see it is installing APK on the emulator. So here is our simple login application. This login application we designed with the linear layout and linear orientation is linear layout with the orientation vertical. When you use a tap on this, you will find a simple keyboard comes and you can always enter any value, let's say lorem. And this button is given by the operating system, so it knows there is one more component available in the screen. You can press the next and it will go to the password text field. We can again enter a lorem. Now you can see these characters are converted into a black dot. And now to dismiss the keyboard, we can always press this check mark button. Now the keyboard is dismissed, and now if you want to log in, you can press on this login button. Now this login button is doing nothing. It is not handling any type of event. To handle the event for our login application, we need to bind these components in our main activity.java file. To bind the component in our main activity.java file, this activity, this is app compact activity class, gives us a method that is find view by ID. We are going to bind this component to a specific class, to a specific data structure with the method called find view by ID, and then we will use the explicit typecast to convert that object from view object to a specific. data structure. So here we require three components. One is edit text, which takes the input from the user, password, which we will take the password from the user, and the login button to handle the login business logic. So let's go. Let's create three components in our main activity. We can say private, then it is type of edit text. So here we can say username edit text, password edit text. Then we can say button, and we require login button. In Android, we will always bind this user interface inside onCreate method. This onCreate method is get executed by the operating system when you start the activity, and here when we start our application, this main activity is our main activity, which is a launcher activity, and it is started by the operating system, and the operating system calls this onCreate function. There are more 6 functions available inside this activity which we need to override and which are the life cycle of application. Then I will tell you later on. But right now we need to bind this component, that is username ET, password ET, and the login button. So to bind this component, we can always say username ET, that is a object of edit text, is equals to find view by ID r dot id dot, we can say username edit text. So whenever we say username underscore edit text, it always goes to the activity underscore main.xml file. From this XML file, it will try to search a component which has ID username underscore edit text. So once the program will parse this file, it will always return the edit text type of object. But wait, here you will find that find view by ID method returns a view type of object, while we require edit text type of object. So here we need to explicitly typecast. There are two ways you can do it manually. We can say it is of type edit text. And another way is like you can click on this find view by ID method. You will find a red bubble coming up. Click on this red bubble and you can say cast to Android widget.editText. So it will automatically typecast. Same way we can do it for the password edit text, and here we can say find view by ID r.id. password edit text. Again, you can click on this line always and you will find a bubble cast to android.widget.editText. Next is we require a login button. Login button is equals to find view by ID r.id.login button. Let me check whether we have provided an ID for the button. No ID is there, so let's add the ID android:ID @+ID login underscore button. Again, you can typecast. Now we have binded all the components we require from this activity underscore main.xml to our business logic, to a Java file. To handle the event on this button, we need to add or we need to implement a listener which is available in Android core library, and that is coming from android.view package, and the interface name is onClickListener. This onClickListener gives us a callback method that is of onTypeClick, which gives us a view type of object. So let's implement this onClickListener. To implement this on-click listener, we can always use this implements keyword from on our class line, and here we can say on click listener. It is coming from android.view.view package. Let's implement it. Now again you can see an error. This class is saying the interface you have implemented, it has a callback method which is not overridden in this class. So let's override this method inside our class. You can press on this line, so bubbles comes up, and here you will find implement methods. Implement method will tell you inside on-click listener there is an on-click method which you can select and press OK. So you will find this on-click method is there. Now to set this on-click listener on our login button to handle the event, we can say login button dot set on-click listener and this. This will refer to an on-click listener which tells us that any event happened on this login button is handled by this main activity class with the help of this on-click method. So let's put something to check whether we are getting an event for our login button. So here we can use another component which is available in Android, that is called a toast. So here toast can be created with the help of toast class. We can call static function on this toast class. We need to pass 3 parameters to it. First parameter is the context, which we can pass with the help of this keyword. Let's say it as a context. Second parameter, we need to tell the message we want to show. So let's say login button tapped, comma. Let's say how much duration you want to show this toast. So in this toast class, there are 2 variables defined. One is length short for the short timing, and another is length long. So let's make it a short duration. This toast.makeText function will create the toast, but to show the toast you need to call a nested function on this makeText, that is show. Let's run this application. Let's use an instant run feature in Android Studio. Instant run feature will change the code which is just changed, and it will upload to the Android emulator very fast. So you don't need to build all the Gradle, all the project every time. It will automatically uninstall the previous application and install the latest one. So you don't have to worry. So again, we can see a simple username, password, and the login button. Now let's tap on this login button to see whether event is get handled on this login button. So let's tap on it, and here you can see login button tapped. We can always write a different type of logic to handle the login, username and password credential with the help of a database, with the help of server connection. So it is our way to handle this login scenario. Okay. Thank you. Hello.
Yes, sir. Thank you, sir.
Yes.